Hi, my name's Jared, and today we're going to be talking about conservation of momentum within physics. The basic rule of conservation of momentum is that no momentum or energy is lost within a system, so therefore mass cannot be created or destroyed. So the same amount of momentum happening before collision must happen after collision. There are three types of problems within the AP Physics curriculum regarding collisions. First, there's elastic collision, inelastic collision, and explosion. Now, with an elastic collision, the two objects combine, and then, the two objects hit each other, and then following the collision, they separate again. Within an inelastic collision, after the collision, they combine together to form one object. In an explosion, the objects are initially together, and then they separate afterwards the collision. So in the first elastic collision, we have the equation mass 1, velocity 1 plus mass 2, velocity 2 has to equal, after the collision, the mass 1, velocity 1, and the mass 2 of the velocity 2 following the collision. We're also given a kinetic energy formula, which is also similar to elastic collision. You must have the same amount of energy before the system, after the system. So in this equation, we're given 1 half mass 1, velocity 1 squared plus 1 half mass 2, velocity 2 squared has to equal, following the collision, 1 half mass 1, velocity 1 squared plus 1 half mass 2, velocity 2 squared. Now, from these two equations, we're able to derive a shortcut equation to help us find the velocity. From these two equations, we can find that velocity 1 minus velocity 2 equals velocity 2 final minus velocity 1 final, or velocity 1 final equals velocity 2 final minus velocity 1 plus velocity 2. Now, we have an inelastic collision. In an inelastic collision, we have mass 1 velocity 1 plus mass 2 velocity 2 equals, in parentheses, mass 1 plus mass 2 times velocity final. So that shows that the two masses are combined after the collision. The same, except flipped, is for explosions. So the two masses are combined initially, so in parentheses mass 1 plus mass 2, close parentheses, times velocity, is equal to mass 1 velocity 1 plus mass 2 velocity 2. Let's get started. So our first problem is an elastic collision. We have a particle of mass 4.0 kilograms initially moving with a velocity of 2 meters per second collides elastically with a particle of mass 6 kilograms at rest. Calculate the velocity of the 6 kilogram ball after the collision. So using the equations I just gave, try and solve this on your own. You can pause the video if you want. Okay, hopefully you found the problem quite simple. If not, I'll walk you through it right now. So we have 4 kilograms and 2 meters per second as our mass 1 and velocity 1. And we have 6 kilograms and 0 meters per second, since it is at rest, of our mass 2 and velocity 2. Now this is all we know. So we have to use our kinetic energy formula to find the final velocity of the two objects following the collision. So using the kinetic energy formula, we plug in 1 half of the 4 kilogram object and its 2 meters per second squared plus 1 half of the 6 meters per second times 0 meters per second. And that's all equal to 1 half 4 kilograms times 0 meters per second, and it doesn't have to be squared because 0 squared is 0, plus 1 half 6 times velocity squared, which is the velocity we're looking for. So following this, we're able to simplify and receive 8 plus 0 is equal to 0 plus 3 times velocity squared. Further simplifying, we get 8 equals 3 velocity squared. Dividing by 3 to receive v squared alone, we get 8 divided by 3 equals velocity squared. Then the square root of 8 divided by 3 is our velocity. So the velocity of the 6 kilogram object is square root of 8 divided by 3 meters per second. Easy enough. Let's look on to the second problem. We have two balls. The first ball has mass of 0.54 kilograms and is traveling 7.1 meters per second to the right. It collides head-on elastically with a second ball of mass 0.95 kilograms traveling 2.8 meters per second to the left. After the collision, what is the speed and direction of each ball? So I'll give you a few seconds to figure this out. Alright, let's get straight to it. So we have two balls, so let's list out our givens. We know that the first mass is 0.54 kilograms, and the velocity of that mass is 7.1. Now the second mass is 0.95 kilograms, and the velocity of that is negative 2.8 meters per second, since it is heading in the opposite direction of the first ball. So now we can use the equations of elastic collision to find m1v1 plus m2v2 equals m1v1 final plus m2v2 final. But now, using our shortcut equation from prior, which is v1 minus v2 equals v2 final minus v1 final, or v1 final equals v2 final minus v1 plus v2, we can use this to solve for one of the velocities. So I personally took out v1 final and substituted it for v2 final minus v1 plus v2. So now our equation is m1 v1 plus m2 v2 equals m1 times, in parentheses, v2 final minus v1 plus v2, close parentheses, plus m2 v2 final. So after further simplifying to solve for v2 final, we're left with v2 final equals, in parentheses, 2 m1 v1 plus, in parentheses, m2 minus m1 times v2, close parentheses, all divided by m1 plus m2. Now we can substitute our variables, and we receive that v2 final is equal to 4.4 meters per second. Now, knowing the shortcut equation, v1 final equals v2 final minus v1 plus v2, we can substitute the variables we have in. So we now know v2 final, v1, and v2. So v2 final equals 4.4 meters per second, as we just found. v1 is 7.8 meters per second, and v2 is negative 2.8 meters per second. So now we're left with v1 final is equal to negative 5.5 meters per second. So those are two velocities. The velocity of object 1 after the collision is negative 5.5 meters per second, and the velocity of object 2 is 4.4 meters per second. Now, let's move on to inelastic collisions. So we have a 4 kilogram meatball, which is moving at a speed of 6 meters per second directly toward a 2 kilogram meatball, which is at rest. The two meatballs collide and stick together. What is their velocity immediately after the inelastic collision? I'll give you a few seconds again. Alright, let's get straight to it. So we have the basic inelastic collision equation, m1v1 plus m2v2 equals v final times m1 plus m2. So we can solve for v final by dividing by m1 and m2 to get v final equals m1v1 plus m2v2 divided by m1 plus m2. Now we can substitute in for our givens, which is m1 is 4 kilograms times 6 meters per second plus 2 kilograms times 0 meters per second, since it is at rest, all divided by 4 kilograms plus 2 kilograms. And we're left with v final equals 4 meters per second. So that is our answer, 4 meters per second. Let's look at another problem. Two meatballs are speeding directly toward each other. One is a 4 kilogram meatball moving with a speed of 6 meters per second, and the other has a mass of 2 kilograms and a speed of 4 meters per second. If they collide inelastically, what will be the speed of the resulting 6 kilogram meatball immediately after the collision? So again, using the equation after solving for v final, we just substituted in the variables. We have 4 kilograms times 6 meters per second plus 2 kilograms times negative 4 meters per second, since it is heading in the opposite direction, all divided by 4 kilograms and plus 2 kilograms, which gives us a velocity of 2.7 meters per second. So that is our final velocity. Now let's look at something slightly more complex. We have a 1,000 kilogram car traveling east at 30 meters per second, which collides with a 3,000 kilogram truck traveling north. Note, there is no given velocity for the 3,000 kilogram truck. After the collision, the vehicles stick together and the combined wreckage moves at 55 degrees north of east. Again, no velocity given. What is the speed of the truck before the collision? So, we have two objects, yet again, colliding and combining together. But what is different about this is in 2 dimensions. We're now dealing with both an x component and a y component. So the 1,000 kilogram car is traveling in the x component, while the 3,000 kilogram truck is traveling in the y component. So we know that momentum is equal to m car v car plus m truck v truck, but yet there's also the x and y component. We have to divvy into this. So we have the mass of the car, which is 1,000 kilograms times 30 meters per second in the x direction, so times x, plus 3,000, which is the mass of the truck, times the velocity of the truck, times the y component. So let's look at the x component first. We have 1,000 kilograms times 30 meters per second is equal to the combined mass of the truck and the car, which is 4,000 kilograms, times v final cosine of 55. So we can solve for v final to further help us in the problem in the later steps. So 1,000 times 30 is 30,000 divided by 4,000 times cosine 55. Now we use cosine because it is in the x direction. And whenever anything is involving the x direction, we use cosine, and in the y direction it is sine. So dividing by that, we get v final is equal to 13.08 meters per second. So this will help us further solve the speed of the truck before the collision, since we now know v final. We can use that within the y component. So looking at the y component, we know 3,000, which is the mass of the truck, times the velocity is equal to 4,000 v final times sine of 55. Again, we use sine because in the y direction we use sine. After solving for v truck, we multiply 4,000 by v final, which is 13.08, by sine of 55, and divide that by 3,000, and we receive the velocity of the truck equal to be 4.28 meters per second to the north. All right, that was slightly hard, but you have to know that when you break it up into two components, into the x component and the y component, it is much easier to solve. Most of the time when you're trying to solve for the initial velocity of either in the x component or the y component, it helps to find the final velocity first. Now let's look at our last problem, which is dealing with explosions. We have a 5-kilogram cannonball is loaded into a 300-kilogram cannon. The cannon is at rest when initially fired. When the cannon is fired, it recoils at 5 meters per second. What is the cannonball's velocity after the explosion? So we know the equation is set to be that m1 v plus m2 close parentheses times v is equal to m1 v1 plus m2 v2. So we have our givens. M1 equals 300 kilograms, M2 equals 5 kilograms. V initial is 0 since it is initially at rest. We know V1 equals 5 meters per second. So the velocity of the cannon is 5 meters per second since it recoils back. And we don't know what the velocity of the cannonball is. So we have 300 plus 5 times 0 meters per second equals 5 meters per second times 300 kilograms plus 5 times V2. So now in this situation, I'm assuming that 5 is in the positive direction. So the cannon recoils in the positive direction. So we know that V2 will have to be negative. So we're left with 0 equals 1500 plus 5V2. We can move over the 1500 to receive negative 1500 equals 5V2. Divide by 5, V2 is equal to negative 300 meters per second. So the cannonball is traveling at a speed of 300 meters per second in the opposite direction of the cannon. That's all our problems for today. If you have any questions, feel free to ask me or Mr. Purguay, and I'm happy to help. Thank you.